I'm going to talk about the SAS Similarity Theorem. Let me start by stating what the SAS Similarity Theorem says. All right, so if two triangles have two equal corresponding side length ratios, and the corresponding angles between those sides are congruent, then the triangles are similar. So remember that to establish that two polygons are similar, we need to show that all the corresponding side length ratios are equal and all the corresponding angles are congruent. Okay, so the SAS theorem is telling us that we only have to establish some of that, and we get to assume the rest. All right, so give me a minute to make a picture, to make an example, and then we'll continue. All right, suppose you had these two triangles in the picture and you knew the side lengths given and you knew the angle measures given. All right, could we establish whether or not these two triangles were similar? All right, we can't use the AA similarity theorem because we don't have enough angle measurements. We can't use the SSS similarity theorem because we don't have enough side lengths. All right, but we can still make progress. Let's first compare the corresponding side length ratios that we have. So 10 over 20 is equal to 11 over 22, and we have the angles in between the sides that we just talked about, that we just were analyzing the side lengths of. The angles in between those sides are congruent. So therefore, by the SAS similarity theorem, we know that these two triangles are similar. All right? That was sufficient. Now, if you wanted a more rigorous argument, okay, to convince you, let me show you what you could do. So as before, give me a minute to make a picture. Okay, so I've drawn two triangles and I've named the vertices and the side lengths of both triangles. Let's assume we had a similar situation to the last example. So assume we knew that A over X was equal to B over Y, and we knew that angle C was congruent to angle Z. Okay, so The question is whether that's enough to show that the two triangles are similar. All right, so the way to establish that would be analogous to what I did to in my outline of a proof to show that the SSS similarity theorem was true. You would draw a line segment in the bigger triangle as follows. All right, and let's call the points of intersection U and V. And you would choose U and V so that XU was equal to B, and so that UV was parallel to ZY. Okay? Now, you can show that the little triangle inside the big one is similar to the big triangle. We've got corresponding angles with respect to a transversal cutting two parallel line segments. Okay, and we know that both of those overlapping triangles have the angle X in common, right? So by the AA theorem, we know that those two triangles are similar. AA theorem. Okay, now if you can show that that triangle XUV, if you can show that triangle XUV is congruent to the small triangle on the left there, then you've established that triangle ABC is similar to the big triangle. Okay, so I'll leave the rest of that as an exercise, but that's what you would do if you wanted to prove beyond a shadow of a doubt that the SAS similarity theorem was indeed true. Okay? Now, I'd like to show you how you can establish a new theorem using the SAS similarity theorem. Give me a few seconds to make a picture. All right, so I've drawn a line segment inside of a triangle from one side of the triangle to the other. All right, now is this enough to show that line segment XY is parallel to line segment WV? Suppose we knew that that line segment divided the sides of the triangle such that the following ratios were equal. A over A plus B is equal to C over C plus D. Okay? So I want to know if, assuming that, can we show that XY, is that parallel to, the line segment XY, is that parallel to WV? Can you establish that it is or isn't? Okay, so pause the video and think about that now, please. Okay, so I'll go ahead and show you how you could reason this out. So we've got a small triangle overlapping a large triangle in the picture, right? And we can take it as a given that two corresponding side length ratios are equal, okay? And we can also take it as established that the angle in between those sides, the angles of the two triangles, are congruent because both of those triangles have angle U in common, okay? So by the SAS theorem, we can state with certainty that the little triangle and the big triangle are similar. Okay? Once we know that they're similar, we know that all the corresponding angles are congruent. So let me go ahead and denote that in the picture. Okay? But now that we've established that, we've got corresponding angles with respect to two line segments cut by a transversal. Those two line segments are line segments XY and WV. Okay? So because the corresponding angles with respect to the transversal UW, line segment UW, because those are congruent, we know that they are the line segments in question are indeed parallel. Okay? So it all followed from the SAS theorem.